Okay, today we are studying absolute value. So my question to you in this first equation, what solutions would work to make that a true statement? What solutions would work to make it a true statement? Go.
Like the plus minus.
Okay, what solutions are going to make this?
5 and negative 5. I don't know the second one.
5, let's try that. What is the absolute value of 5?
5.
Is that a true statement?
Oh, wait, yeah.
So that works. 5 works. Okay, what else? Yep.
Negative absolute value of 5.
So if we try if we try negative 5. Okay, just substituting in the x for negative 5. That becomes 5 equals 5. That works too, so it would be 5 or negative 5. What you were trying to say, yes, is plus or minus 5. We can write it either way. Like this, we can write it like this, because two things would make that a true statement. You guys with me? Okay, what is absolute value, by the way? Let's talk about what is it. Go, Gracie.
Absolute value is a number's distance from 0.
A number's distance from 0. So, for instance, if I have on a number line, here's 0, here's 3 8/10, here's negative 3 8/10, and I were to take my measuring tape and measure from here to 0, what would it measure? 3 8/10, because there is no negative measurement. I mean, we look at shoe sizes. I can't walk into the shoe store and say, may I please have a size negative 5? They're going to look at me like I'm crazy, like I'm from Harry Potter world. We don't have negative. And the same thing, if I take my tape measure and I measure from 0 to 3 8/10, it's still going to be 3 8/10. It's distance from 0. It's not the opposite, it's distance for 0. So what we do with our absolute value equations is we basically try that and prove it. What would work on the next one? Yes.
The negative of the absolute value of...
So what would I fill in there? Okay, let's just go like, I get to fill in for x, right? The rest of it's...
It could be 5 or negative 5 for x.
Okay, let's try it. 5. What's the absolute value of 5?
5.
Does that work?
No.
Okay. What else can I try in there? Anything else? Noah?
Could you put the negative sign before the...
No, because this is the equation that's given. The only thing I'm able to change is the variable. Varying. So what else could I do? Yes? Huh? N? N, X, same thing, right? It's a variable. Tony? I can't hear you, what? I'm not trying to get X alone. I have to figure out what is X allowed to be. I'm within the parameters of this. Okay, anybody? Let's try about negative 5. Does that work? 5 equals negative. So what do you think? Chloe?
Doesn't it not work because absolute value can be negative?
Yes. Absolute value. So anytime absolute value is equal to a negative quantity, it's going to be no solution. Now, I'm going to tell you, this is going to be a really bad joke that I'm going to play on you. Evil math teachers do this all the time, but I'm going to be nicer and I'm going to tell you. I'm going to give you a really hard equation inside there. It might be a calculus equation. It might be a quadratic equation. But I'm going to do this. Now, it doesn't matter how difficult it is. Because what are you going to say? When absolute value equals negative, what are you going to say?
No solution.
Yeah. Don't spin on this problem that's like, oh, I kind of get it, but I don't get it, and right? If it's so hard, I'm not going to give it to you. Right? So remember, that will be the trick. All right, so let's start on this side. Gracie, number 1, what would the solutions to number 1 be?
X can be positive or minus or negative 10.
Good. Fiona, number 2.
X could be positive or negative 4.
Good. Next one.
X could be 0.
Just 0. There's no negative and positive. Good. Next one. Maddie, good. No solution. Next one, Chloe.
X could be 14.
Is that it?
Negative 14.
Will negative 14 work too?
Mm-hmm. Yeah.
Both. Plus or minus 14. And then next.
T could be 3/4 or negative 3/4.
Yep. Excellent. Okay, questions? Okay, now we're going to start to solve equations. So let's just look at this theoretically. If I were to cross that out and there weren't an equation in there, what do we know the value of this has to be? 15. Or negative 15, because of this absolute value, right? The negative 15, it will become positive. So what we do when we have a situation like this, an equation, we branch it off to 2 equations and we write the exact same equation, except we make the second equation equal to that negative 15. Because we know that this in here can equal positive 15 right here, or negative 15, which would be right here. Yes, you're understanding?
Mm-hmm.
And then we solve them. Okay? Right after this, I'm going to try and fix this. Okay, we're going to solve it. So what would I do to solve it? Let's go. Who's next? Brianne.
We would have to add 3 to both sides.
You're going to work on the first equation, and then you're left with?
X equals 18.
Good. And then we're going to go to what? How about Isabella? Good. And x equals negative 12. So I can put my solutions in braces because it's a set, a list, right? This is a solution set. It's really awkward there. And then, or I can check my work now. Substitute both answers in. Negative 12, negative 3 make what?
Negative 15.
And the absolute value of negative 15 is?
15.
Okay. 18 minus 13, 3 is? 15. And 15 is equal to 15. Okay. Let me go back here. Hold on. Pause the recording. Okay, so I just had the question is, why does it go negative 12 to 18? When you're using a brace, it's a list of a solution set. So it's a list of things that can be used as solutions. We like to try and keep things systematic in math, and so we go from least to greatest. If you did not list it, however, least to greatest, it would not be wrong. As opposed to something like this. It has to be in that position. Why? Or if given this, why does it have to stay the way it is? And there's no option to move it. Yes. It's a coordinate. It's like somebody's direct. It's like somebody's address on the coordinate plane. So this has a specific order that it might have to stay in. Here, it doesn't necessarily. It's just a list. But in math, we like to keep things systematic, in order, and so they go from least to greatest. It would not be marked wrong if you did 18 negative 12. But you do need to put it in the braces and not. And I'm not crazy about that. Like, I usually just do this when I'm making my braces. Okay, so let's go to the next problem. What would we do first? Who did we leave off on? Tony went? Did Tony go? Yeah. Yeah? Did you go before? Okay, so what do you think we would do? I'm going to say with these absolute value equations, we always isolate the absolute value. We want to get the absolute value alone so that we can branch. So what would be the first step? We're going to subtract 7. Okay, and then we are left with absolute value equals 25. Now what would I do, Tony? Or equals negative 24. 5. Positive 25 and negative 25 to account for that. Okay, questions? Okay, finish it up. Pause the recording and you guys finish it up. Okay, let's check our work. We're adding 3. 2x equals 28. X equals 14, and we're adding 3. We get x equals negative 11. So what order would it go in? Negative 11, comma 14. And that would be the two solutions. And you can check it mentally. You can check it here in the original problem, or you can check it here. It's equivalent. 2 times negative 11 is negative 22, and negative 3 is negative 25. 2 times 14 is 28, minus 3 is 25. So both work. Is that clear? Okay. So the goal when you have absolute value in an equation is get the absolute value isolated, then branch it into two possibilities. Okay. What do you think we would do here? Anybody? Right over here. Is that Max? Divide by 3. Next to means multiplication. By the way, we never distribute into an absolute value. It does not mean you are not, it's almost like this cement wall. Do not try and distribute that. We get rid of it and then we branch. So divide by 3. And then we get, now what would I do? Max, why don't you continue?
The two equations would be x minus 4 equals 6.
And?
X minus 4 equals -6.
Good. Okay, and then I'm adding 4 to both sides, and we get x equals 10, or x equals negative 2. And again, you can go back and check. 10 minus 4 is 6, that works. Negative 2 minus 4 equals negative 6, that works. So do that mental check. Questions? So it's negative 2 and 10. All right, so now we're going to ask, here's what you're going to do. Determine whether each statement is true always, sometimes, or never. Always, sometimes, or never. So we're going to do that by testing. You can pick any number. We have 3 basic real types of numbers that we need to test. Can you figure out what those are? What?
Odd, even, and prime.
No, we don't need to try odd and even. Yep.
Negative, positive, and 0.
Negative, positive, and 0. So let's see. Does it work here when I have a positive? So if I have, let's pick any positive number. Positive 2. Is this equal? That would be 2 equals 2, right? Let's try a negative. Negative 2. Right? If x is negative 2, is that correct?
No.
Okay, so negative 2 doesn't work. So what are we going to say? Sometimes. That's a sometimes answer. Does that make sense? We don't even need to go to 0 because we found one that's true, one that's not true. So it's already in the sometimes category. Okay, what about number 2? What about number 2? Let's try a positive. Negative, absolute value. Let's go, how about 1? Is less than or equal to 1. That would be negative 1 is less than or equal to 1. That works. Let's try a negative. Negative, absolute value of negative 1 is less than or equal to negative 1. that would be positive, no, that would be positive 1. No, that would be negative, right? So it would be a positive 1 times negative 1 is negative 1 is less than or equal to negative 1. Works with the negative. Let's try one more, 0. Negative absolute 0 is less than or equal to 0. 0 is less than or equal to 0. That works. So what do we say? Always. Okay. Why don't you pause the recording and you try with your table partner. See if you can figure out 3 through 6. Pause the recording now. So now let's check our work. Number 3. Let me hear from the front row. What did you get?
We got sometimes.
Sometimes. When is it true and when is it not true?
It's true when you put a positive.
It's true. So if x is 4, it's going to be greater than negative 4. When is it false?
If your number in the absolute, or if your number is a negative.
Negative 2 becomes a positive 2 is greater than negative 2, which would be a positive 2. Good. It's not greater than, it's equal to. Good. Excellent. So, there we go. Number 3. What group would like to volunteer their answer? Number 3. Okay, go.
For number 3, it's sometimes.
Sometimes. Tell me when, what would make it, oh,
We just do 3.
oh,
Number 4.
sorry, 4.
Number 4. Number 4. Number 4 is never,
Why?
because if the absolute value of x is always going to be positive because there's no negative before it, then it'll always be more than 0. Not
Yeah,
less.
all positives are greater than 0, so that's a negative. 5. Don't all volunteer at once. 5. How about Chloe Cross's group? You put sometimes. So let's try and prove it. Okay, so let's take a negative. Negative 2 is less than negative 2. So that would be a positive 2 is greater than, this is 2 times the negative is negative 2. That works with the negative. Now let's make it positive. I'll do negative absolute, I got to think of a positive number 2 is less than or equal to the absolute value of negative 2, right? Because that negative is there. So I'm really just replacing this and this. So this is a 2 times a negative makes it negative 2 is less than 2. Okay, let's try 0. Negative absolute value of 0 is less than absolute value of 0. Where did you find your counter example? Do you remember? Huh?
Our counter example, like proving that it was never?
Yeah.
Proving that it was sometimes?
Sometimes, yeah.
We did it with, when it was, 0.
Okay, so then when it simplifies, that's going to be a 0 is less than 0. It can't be less than, it's equal to. So that is the counter example to the sometimes. So does everybody understand? Okay. And then I'm going to show you, oops, the last one is always why. Yes.
It's always because anything in absolute value is positive, so it's essentially just saying x equals x.
Yeah. And if I put a positive there, let's do positive 3 equals negative 3. That's going to still be 3 and 3. Yep. Yes.
Isn't it still going to be negatives?
No, because what happens here is, since in the first one, what I'm inputting is just the x, if x is negative 2, right? And here, these two make it positive. And then the absolute value of 2 is 2. Here, the absolute value of negative 2 is 2. So they're both equal. Then if I had 3, the absolute value of, it's always positive, it's never opposite. It's not opposite. The absolute value of 3 is really 3. The absolute value of negative 3, how far is negative 3 from 0? It's 3 units. And then if I substituted 0, it works there too. Because that 0 equals 0. Does that make sense? Okay, so now we've got some more, and determine whether each statement is true or false for all real numbers. If it's false, find the counterexample that proves it false. So, again, we're going to take a negative, a positive, and 0. Would 0, does 0 make it a true statement? No. So 0, it's false, and 0 is that's the counterexample, yeah, sorry. Number 2, what are we going to substitute in? How about a group I haven't heard from? How about right here, Jamie and Brianna?
It can be true, with all.
Positive numbers and negative numbers and 0. So it's true. Good. Oh,
No.
that's right, because remember, we're replacing x for negative. So, negative 7 equals negative 7. That becomes 7 equals negative 7. That's what proves it false. All right, I want you to pause the recording and do the rest of them with your table partner. Go. Does everybody understand a counterexample? Who wants to give it a go? Jamie's group.
I said it's false for negative.
Okay, why? Because negative doesn't work. So let's try it. He said false. So let's do negative, and I'm substituting in a negative 2 equals negative, negative 2. This would become a positive 2 times a negative makes it negative 2, and that becomes a positive 2. Because 2 negatives next to each other means multiplication. Perfect. Okay, next one. Yes. True. Couldn't find anything. Positives worked, negatives worked, 0 worked. Good. Next one, number 5. Let's go, Aton. What? Did he say always? Well, that would be true, okay? And then the last one, also true, because there's no counterexamples. Again, what's a counterexample? Yes, Julia? That proves an equation wrong. A counterexample is an example that proves something wrong. All right, that's the recording. We're out.